chairs in the front here for those people who are just hanging out in the back. And there's like by the pole, the whole middle part of that row is open. So you should be able to find seats. We're going to be cozy in this little room. Ha 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 ha.
Yes.
Not late enough.
Yes.
Okay. Let's go ahead and get started because by my computer's clock, it's time. This is the Note Well by Thursday. You've probably read it over and over and over, but the big thing is, remember, these are your rights and responsibilities to participate here in the IETF. Please treat each other with respect. And, you know, you can certainly disagree with an idea, but that doesn't mean you attack the person presenting the idea. We have a long agenda. We will probably need an interim. We're going to do the best we can. This slide contains things that have moved along in the process. The first one actually now has an RC number. And then the rest of these are with the ISG or the RFC editor. We put them on the agenda for the authors to share anything that is happening that is causing changes to the documents. We're not talking about adding commas. We're talking about, you know, things that the working group should be aware of. So that will be the focus of those discussions. And then the next grouping is PKIX related documents, and you can see A through J, and then SMIME related documents, A through F, and then documents that people want to present for consideration for adoption. So we've got a lot here. Please focus on the things that are big changes and not the editorials. Are there any agenda bashes? Bernie. Bernie, we can't hear you.
Okay, is it now better?
Yes.
Turn the mic on. I have to leave after 1 hour for another side meeting related to emails, so I would be grateful if we could discuss the end-to-end user document before that, and I suggest together with the header protection because those are interrelated.
Okay, how about we do that right after the documents that are with the ISG? Would that be soon enough?
I guess so, yeah.
Okay, great. All right. So we did not receive slides from everyone. I'm assuming that means they can summarize what's going on without slides. Let's see. Who's first? So Hendrik, you did send slides.
Yeah, so I did send some slides, and I'll do it quick. There are no major changes since. So next slide, please. No, this is
the wrong slide
deck.
Sorry. That's for later. Is this lightweight? Is that what you called them?
For lightweight, yeah.
Yeah. Okay.
Okay, so next slide, please. This is about 3 documents that are in the RFC editors queue. The CMP algorithms is there since, I think, May last year. Already they are in a cluster. There is some minor updates to be done during Auth 48, but then they are currently proceeding through the editors queue. Next slide, please. Same with CMP updates. We did identify, since they were approved in June, 2 issues that were discussed on the mailing list and will be fixed during Auth 48. I just added the links to the mailing list on the 2 topics. And one general thing that, to address the request from the ADs to provide a 4210 bis and 6712 bis to the section 1 of the document, to just let the readers know. Next slide, please. The lightweight CMP profile also in RFC editors queue. The only thing next to a typo I spotted is I would like to introduce an abbreviation in the headline of the document, because it came out that other documents want to reference this one by an abbreviation, and not to get confusion, I would like to introduce this abbreviation briefly in the document. There is a 4th document in this cluster, which is also in the editor's queue, CMP transfer, or co-op transfer for CMP. This is in the ACE working group, but also proceeding through the editor's queue. Thanks, that's it.
This community really needed another acronym.
And Roman pointed out that we missed the NFTKU is not here, but it's in the RFC.
Right. Because we put it down here.
Yeah.
Okay. Is anything from Corey on issue mail?
All right, so CA issue mail really had no substantive changes after working group last call. There were 2 minor edits, the first of which is a little more specificity around what exactly certifying an email address is. So some language was added to clarify that that means that an email protection EKU is added, and there's 1 or more email addresses expressed in the SAN, either as a RFCA 22 name or an SMTP UTF-8 mailbox. And then there was another change that was requested, and that was to clarify that certification authorities that are implementing the spec still need to carry out the appropriate validation that they were doing previously, or whatever's specified by the certification policy. Kind of the CAA checking isn't a substitute for actually performing the validation steps. So pretty small changes, pretty surgical. Didn't really think it involved a extensive treatment or a slide deck. So that's pretty much about it. Any questions? All right, thank you.
Cool. All right. DKG, are you talking to header?
Hello, I'm Daniel Kahn-Gilmore. I did a process hack. My slides for header protection, which are here at the top of the agenda, also contain the stuff about the end-to-end mail guidance document, which was at the bottom of the agenda, but I will present both of them now.
Fair. I don't see them.
You don't see them?
There they are. Nope.
So, right, next slide, please. Short slide deck. The header protection draft, which is what I'm supposed to be presenting right now, had very minor nits cleaned up during received from working group last call, which put it in a missing references state because it's waiting on the end-to-end mail guidance document. Next slide, please. And the end-to-end mail guidance document has had substantially more revisions and more feedback since the last IETF, which is great. Thank you for the folks who commented on the list. Since the last IETF meeting, we added guidance to that draft on draft messages, on local certificates, like how you deal with your own cryptographic material and certificates, guidance about intervening mail user agents, that is message forwarders, typically mailing lists, but maybe if you're bouncing a message as well, and some commentary about having external sub-resources in text HTML parts and how problematic that is. We don't really know what that means for signed or encrypted mail. If you have a signed or encrypted email and the email has text HTML, and that text HTML refers to things from the internet that we don't know what they are, it's not clear what the confidentiality or authenticity properties of that rendered HTML actually mean. So there's additional text in there. If you think any of that sounds pretty weird, you should have read the document, or you should have read the document maybe, but start now. Better late than never. We also identified that there's a lot of additional things that we don't understand about properly doing end-to-end encrypted mail. And some of it we understand is problematic, but we don't have solutions for. And rather than have this document last indefinitely as a forever undone specification, because we haven't figured out encrypted email for the last 25 years, we thought we would publish this document and move all of the to-dos into a sort of statement of future work as an appendix. So that is a hefty appendix. It's worth looking at. If you're interested in end-to-end encrypted email, I encourage you to look at those. There's actually bite-sized problems in there that you could work on a separate spec for, but we don't want to put that all in the current draft. We want this draft to be out. That way we can avoid the misref, and we get the header protection draft out, and we can put the substantial useful guidance that's in there out as an RFC as well. So Russ, Elliot, and Stephen in particular gave the most substantive feedback. Stephen, I'm looking at you. I'm hoping that you can give me responses for my responses to your feedback at some point soon. But the thought here is this document should be in working group last call as well, so that we can get that and the header protection document out of the RFC editor's queue. Next slide, please.
Before we move on real quick, one thing we have seen refs used in HTML is in signature lines where people like to put their logo and they just fetch it off their website.
Yep.
Right. And so it really isn't part of the content of the message, but it's certainly covered by the signature.
Yep. And it's a pretty clear argument to me that we should be telling people, if you're sending a signed message or you're sending an encrypted message, don't do that. Because it's very difficult for the receiving mail user agent to understand this part isn't part of what people would care about being signed. That kind of semantic is something that receiving mail users can't do.
Stephen.
Steve, do you want me to respond to your response? I mean, here and now.
Can it be done in one sentence?
Yes.
Go.
Oh, by me?
Yeah.
So yeah, I had a look through it. I'll reply to your mail. I think the only substantive comment, the only major comment I have left is, do we know what the implementers of the most commonly used mail user agents think of the guidance draft? And if we don't, is it okay to go ahead anyway?
I mean, this draft has been out here in the LAMPS working group. They're aware of it for a while. I have tried to scare up implementers to take a look at it. And so if they don't respond, I don't know what to do. Like the lack of response, if the lack of response blocks a document, I'm at a loss. I look to the IETF for guidance on what to do in that situation.
Let me just say what the chairs have done.
Okay.
We've reached out to several of the big implementers, got, when this work was beginning, buy-in, and many of them changed jobs. It's just the fact of where we are.
Okay.
So I also, to be clear, if a big implementer comes along after this document is released and says, whoa, this is all wrong, here's what we should be talking about instead, I do not object at all, and I hope the LAMPS working group would not object at all to there being a rapid BIS that corrects anything that's wrong. But blocking it indefinitely.
I'm not asking. I phrased the question. If the working group and if the chairs think the working group is okay with going ahead, we tried, didn't get. We don't know the actual state. If that's the position, then okay. I'm not trying to block out.
We do know that they do not all follow all the guidance.
Yeah,
That's correct.
yes, we know that. Yes.
Yeah.
But it just seems odd to be kind of giving this really well-intended guidance, but not knowing how much of it might ever get.
It's definitely odd, and it was a great comment, and thank you for bringing it up.
Okay, so go away.
If you have better ideas what to do, we're all ears.
Do you have another idea for what word begins with L that could go in the name?
No. Sorry, I'm not logged in yet, but just a quick answer to Steven's questions. We received some feedback that some comments might be coming from one of the implementers. And I cannot tell who the implementer is.
Yeah.
Okay.
Does this hypothetical person have a time scale?
That's the question I asked.
Okay, thank you for asking.
For the record, we don't know. Yeah. So let me just run through these. So the future work section that's in this end-to-end mail guidance document has a number of things. As I said, this is like a great list of things to work on. If you work on email, consider trying to solve some of these problems in a future draft. The ones that I have highlighted in yellow here are ones that are explicitly called out in the introduction as things that we think are particularly relevant. Thanks to Elliot for pushing it to be the document to be more upfront about the fact that there are gaps. I could talk indefinitely about all these points, but we have a huge agenda, so I'm not going to go through them. I'm just pointing out that there is lots of work to be done on making sure that we have usable end-to-end encrypted email, and that is not complete yet. Next slide. So the authors would like to see this wrapped up and put out the door, and so we can continue to do the remaining work that's left. So any more comments? I'm happy to take questions.
Stephen, would you formally reply to the last call? Because right now, the state of the mail list is that you have, thank you.
Okay. I'll yield the floor.
One thing quickly. So I figured out what happened with the agenda. The agenda that's there is actually a little bit stale. There's the mailing list, for the one that's on the 117, and that's why NFVQ is in the wrong spot. Yep.
So item I here is actually with the ISG, and because the working group last call ended on the 12th, we called consensus. It's been pushed forward. Yeah. Okay. So yeah, I pulled the one from the from the data chart, the slide deck. Okay. So I think Henrik is back to talk about the BIS documents.
Yeah, so I'm back with a 4210 BIS and 6712 BIS. Next slide, please. 6712 BIS, nothing to report. We incorporated the changes from CMP updates, and as of now, there are no further to do. So the document is waiting for 4210 BIS. Next slide, please. So these are the changes we did since IETF 116. We mainly worked in a group together with John and Mike, and David Hook also joined in once on the adding support for CAM certificate management. We had another try to specify the way how to do message protection using CAM keys and CAM certificates. This time, I think we are quite close, and we did the best practice, would say, from CMS CAMARI. We did introduce a new algorithm identifier, CAM-based MAC parameter. This is kind of following the practice of a password-based MAC parameter and Diffie-Hellman-based MAC parameter as it is already in 4210. Then we introduced an info type value to transfer the CAM ciphertext, and we introduced a CAM other info structure to provide context information for the KDF. Next slide, please. Mike?
I want to point out, it's actually not on the slide, Mike Answorth. It's not on the slide. Maybe it should have been. The change here was that we undid the HPKE usage, right? So I just want to call that explicit in case anyone's a big HPKE fan and thinks that it should have been HPKE based.
That is right. We got the guidance from the working group back in IETF in London that we should use HPKE. We did a try, but we stepped back from that. Also because of quite struggling with the HPKE for this specific use case in CMP. And as a decision for CMS CAMARI, we also feel like this approach is much more appropriated because we do not set up any sessions and have much communication channels. So here we see the ASIN1 structure we introduced, so the CAM password-based MAC parameter where we have the KDF output length and the MAC algorithm in. Then we have the info type value CAM ciphertext info to transfer the CAM algorithm identifier and the ciphertext output of the CAM NCAPs, which can be transferred either in a general message body or in an arbitrary message header in the general info field. So we'll see on the next slide how this could work out. And then we have this CAM other info sequence, which has a static string, which should be CMP CAM. Then we have the optional fields from the message header, which is transaction ID, sender nonce, receipt nonce. So as we do not know whether the message is making use of these optional header fields, they are also optional in this sequence. Then we added the CAM output length and the MAC algorithm identifier. And we did add the ciphertext itself, because if we thought if there is no transaction ID, sender nonce, receipt nonce, the context would not be really a context information on the PKI management transaction. But this is something we would like to get feedback on.
If you copy this from the document, you have : == instead of : ===.
Oh, sorry.
Okay.
Okay, so this slide shows how the CAM-based message protection would work if the client owns the CAM key. So if the client owns the CAM key, the client first has to send a general message to the server to request a CAM ciphertext. In this message, the client would provide or could provide its CAM certificate to the server. The server could then provide the CAM ciphertext in this new CAM ciphertext info value in the response message. Then the client could decapsulate the shared secret and by using the KDF provides a shared secret key for the MAC and then sends the request it wishes to send. Here the example is the initial request message with a MAC-based protection using that shared secret key. On the server side, the server can then use the shared secret from the previous step and derive the same shared secret key to prove or to validate on the MAC-based protection. And as this is just the key derivation for the client side. The server is free to use whatever credentials it has for message protection. And this shared secret can be used on the client side for message protection for all further messages of that PKI management operation. Next slide, please. If the server side has a CAM key, then it could either make use of this initial general message round trip, but it could also, the client could also incorporate the ciphertext info type value already in the header general info field of the initial request message if it already owns or has the CAM certificate of the CMP server. And then the thing works like on the previous slide. And finally, both mechanisms can also be combined if both sides have a CAM certificate. Thank you. Questions? So the authors would like to get much review and feedback on this approach. We specified this hopefully well in the body of the text, but also with some more details in an additional appendix.
Yeah, I was just, it's John from Entrust, one of the authors too. I was just going to point out, as part of our hackathon, Alexander actually did implement some chem in CMP. So there is an implementation. So we're looking forward to having some more so we can do some interop. But from what I heard, he said it was pretty straightforward. So, and yeah, just wanted to point that out.
Yeah, thanks for the addition.
Okay, the next topic, since I don't see anyone else in the queue, thank you, Hendrik, is the updates to PKCS12 for PBMac1. I did not get any slides on this. Is there any update? Okay, hearing none, we'll move on. Next is Michael Richardson on 7030 CSR adders.
Okay, hi. Thanks. Can I have slide control?
I can do that.
There we go. Wonderful. Thank you. Okay, so the story so far, I've done this slide before. We did this. I noticed actually that it was exactly July 27th last year that we did this last time in Philadelphia. We had some assumptions and some documents about certain things turned out to be wrong, and CSR attributes were poorly defined, and we've now gotten through the point where we have a document that I think at least defines everything as well as could be defined there with some examples. I have some running code. Dan's put some examples in with some, I think, from his running code. And we could at this point, I think, easily go to a working group last call and be done by the next IETF. So this is a little bit, but just to remind you what a CSR looks like, which is basically the thing we're trying to build in. We have only addressed the problem of the attributes, and we haven't addressed the question of the subject there. The subject public key info, of course, gets created based upon, other requests about what kind of keys you want, how big they're going to be, what signatures, what hashes, and this kind of stuff. And so the question is, well, what about the subject name? And so we could do some things, and we thought about, some interesting hacks that would let this, but David had a better choice. So you can read this as well. I just said that. So his suggestion is, well, what if we just, in fact, instead of trying to make up a description of what the CSR is supposed to look like, what if we just sent one? Just, this is a thing, fill in the blanks, and send it back to me with the right place. And so this is an example of what it might look like in a kind of YAML or whatever, like presentation, a highlight presentation. So in this case, you can see the subject says CN equals blank. So you better fill that in. So you have to somehow have a way of distinguishing hoping all of your fields blank is never valid there. And I think that's true for most things. And the serial number, well, maybe you specify the serial number because someone else is going to do this. One of the places where we think that this is actually, and by the way, that's the X520 serial number, not the certificate serial number, just to be clear for everyone. And, challenge password, value null, another place you fill it in there. One of the places we realized where actually this is valuable, we actually do need to set the subject because we need to set the subject, the serial number or some other fields, is actually when we're creating IDEV ID certificates in a factory. And actually there's an effort within the NCCOE's IoT onboarding to do exactly this. And right now it's underway. So that's the second approach, right? So allows us to specify the subject DN, and would of course be lovely if that was the only way we needed to do it. And you can in fact do anything. I had to code my own CSR attribute library based on ASN objects, whereas I probably could have easily used the CSR code that was in the library already. So then it becomes like, well, maybe we just have to keep the old mechanism for the old uses, and in a greenfield situation like IDEV ID provisioning, that you can avoid all of that and just do this new mechanism. And that's discussion, really, that's it.
Anyone have concerns with this approach? Sean's coming to the mic.
I might probably help start someone's problem. So it's great that whoever this David guy is suggests this idea of returning a CSR. That's awesome. That's already in an RFC, and I wrote that one. So that sounds great.
Which RFC? So are we done? We'll just stop.
I think I'm going to shut up and say, nice job, guys.
No, which RFC is it? I don't know. Okay, I have to look. All right. So
send it to the list.
Yeah.
And
okay,
make sure you log into Metaco.
He's leaving the room? No. Anybody else?
He's wearing a nom-com colored shirt, so he
so
can't.
Apologies. I think I may have misplaced my phone. It's RC 8295. Appendix
8295.
It's informative, so it's not the same, but it's there.
Okay. All right. So maybe we just need to reference that and there, and we would still publish this, or should we just throw it all away?
Sean is just shaking his head.
Doesn't know. All right. Well, all right. Let's take it to the list. So,
yeah, take it to the list.
Anyone else? That was David Van Onheim. I say his name right, and I think he's in the list somewhere. Yeah, Ben.
Yuri, go ahead.
David, I'll get your name.
Mike, like I said in the chat, this is a collateral comment, not directly related. I like to run ASN.1 stuff through free compilers, such as ASN1C, and they unfortunately do not support this newish ASN.1 with all those capabilities. It would be
so
look,
I'm sorry. I would love to fix that from you, but 7030 already had that bug. So I don't have a way of describing what is necessary without using that. And 7030 didn't either. So I'm with you. I had no idea what any of that meant, and I had to learn. So like literally when I was writing my code, I'm like, I have no idea what this means. I was just guessing based upon the examples I had. So yeah, it'd be great, Yuri. I don't have an answer for you, and I don't think there's a way for me to change the ASN1 to be both compatible with what's out there and express what needs to be said without those type thingies.
Understood. Understood. Thank you. And to Daniel, it's not fixes. It's a very significant amount of enhancements, which means I have not seen someone to step up and volunteer. Perhaps you would like? Over.
No.
I don't see anyone accepting the arm twist.
Okay, back to the list. And somewhere is that RFC is mentioned, I guess, in the record. Maybe someone write it. Thank you.
Okay, now I'm the key attestation stuff was which has been in flight in a whole bunch of different ways. So I think Mike Ownsworth is going to talk, right?
Okay, so this is work that is new in that I think this is the first time I'm presenting it, but it was on the agenda in Yokohama.
Correct.
Yeah, okay. So this is the second round of slides, but first actual presentation. So we are trying to do carry attestations and CSRs, attestations in the full LAMPS or RATS sense of the term attestation. Next slide. The driving motivation here is a CAB forum change. The driving motivation is starting a month ago, June 1st, public CAs are not allowed to issue code signing certs unless there's proof that that private key is in hardware. And this is, I understand CAB doesn't want Windows binaries yet. Tim's nodding along, doesn't want Windows binaries signed with P12 files or Windows CAPI keys that are not hardware backed. The problem is we don't have good automation to make this run smoothly. And so the public CAs are, I'm assuming Tim's going to keep nodding, really struggling to actually do this validation in a smooth and automated sort of way. So we need like, this is really what's, this mechanism hopefully is useful beyond this use case, but this is really what the time pressure is we need a way to carry these in CSRs so that your HSM can attest to the CA at CSR time that this key really is in hardware. And yeah, once you can do that, then all the other attestation-y stuff, platform attestation, key attestation, you can sort of leverage the whole ecosystem and the CA can pick and choose what it wants to validate from that. Next, question, Uri?
Actually, two quick ones. One, would hardware token such as YubiKey or PIV or CAC card count from the CAB point of view as HSM, or do they
Yes.
require a true HSM?
Well, true HSM depends on how much you like your HSM vendor, but it would be compliant with the requirements for issuing a code signing key that complies with the CAB form requirements.
My reading of CAB form requirements just says FIPS module.
Yeah, it's a FIPS level thing, so
Which means if you want to
so
code
level
on
3
your Android phone, that's technically allowed.
I did not get this discussion. So basically, you are saying that as long as the hardware token, such as YubiKey, is FIPS certified, it is okay. Is it correct?
Level 3. But
Got
yes.
it. Thank you. And are you thinking about quantum resilient signatures?
Okay, let me take those questions two at a time. So so you do raise a good point there that this draft has to consider that, and I'll get to it in a few slides, there are like a bajillion different key attestation formats, depending on if we're considering that, if we're making no assumptions about what kind of hardware we're talking about, we have to support, opaquely any attestation format, like literally could be an Android device. Quantum resistance, I mean, yes, but again, not in scope here. We're just trying to opaquely carry whatever the device produced.
Sorry, this is a pedantic comment. So PIV and CAC are FIPS level 2 certified. They are hardware, but they're level 2, so they won't qualify.
They would not
qualify.
qualify.
3, I don't know what YubiKey's HSM is certified at. If it's 3, I guess it qualifies, but I don't know.
Yep.
Yeah, the point is this draft is being completely agnostic about all of that. If there is an attestation blob, we carry it. Don't really particularly care what it is.
Just as a bit of brief background, who don't follow this as closely, the motivation of this ballot is the previous security level was a end user device with form factor similar to a USB token. So going to FIPS level 3 is a quantum leap forward.
Looks to Phil Humbaker, it looks to me like if you go this way, then people are, it's going to be an HSM in most cases that's controlled by the CA rather than the end user anyway.
Yep.
Because I mean, like, I didn't spend, yeah, I cannot buy a FIPS 143 device for the price of what I pay for my code signing certs.
Yeah, no, that's absolutely true, and that's actually part of the motivation. The desire to have everybody sign their code is incompatible with everybody having and purchasing and refreshing regularly a FIPS level 3 compliant device. So yes, there will be somebody else will probably be holding your key if you can't avoid if you can't afford an HSM.
I would suggest to postpone the debate about whether the CAP form requirements are good, bad, or whatever, yes, to actually get to the real point.
Next slide.
Yes, thank you.
Okay, so the status of this draft. We have been doing a PKIX attestation design team, which has a huge pile of people who represent all the vendors you would sort of expect this work to be represented by, all the big HSM vendors, a number of the big CAs. I've really tried to hold an open process here and invite anyone who has an interest in participating. So I do hope this work is representative of all the people it should be representative of. We used several input documents. So these are all on the agenda. They're certainly all on the LAMPS open documents list. This current incarnation of the draft is supposed to replace and supersede all previous key attestation CSR extension-y stuff in LAMPS. And I believe at this point, all the authors of these things, maybe except Mike St. John's, have publicly said that they're okay with being replaced. Perfect. Okay, so I think we actually do have agreement from all the authors that we can go ahead and do the queue jump thing. But so the last point on that slide is we're doing regular meetings. They are Monday mornings, open invitation email, the LAMPS list. We can shoot you the Outlook invite if you want to participate. So here's the model. We're taking the RATS. So this document fully complies with the RATS architecture. We've taken the RATS architecture terminology concepts. That was a bit of a rework from a previous version that was based on TCG terminology. We're now completely based on RATS terminology. We're using the passport model. The idea is that the CA or RA is a relying party that in this model gets to be completely agnostic about what the content of this attestation is. So we're just providing a shipping container. You stuff your attestation in it. It comes along. The CA or RA forklifts it out, hands it off to a verifier. Conceptually, we're imagining the verifier would either be a utility provided by the hardware manufacturer or a library, or I mean, maybe an external component, maybe a library the CA wrote, maybe part of the CA, but conceptually we're allowing it to be separable. So the CA doesn't actually need to parse this thing. It's just some bits, and CA knows how to take it out and hand it off to whoever knows how to check it. There is the question of nonces. Do you want, attestations in general want some concept of freshness? This is a fantastically philosophical debate with CSRs because CSRs often want anti-freshness. It's often desirable for CSRs to be reusable, for example. So this has been a phenomenal debate about what the concept of a nonce actually means in the context of a CSR. In the context of a certificate request protocol like CMP or ACME, you probably do have a meaningful concept of a nonce, but in general with CSRs you don't. So we've done some fancy footwork around that concept. Next. There are a lot of attestation formats. We are trying to be very not opinionated about them. Next. Yeah, there are lots of different attestation modalities: TPM, ARM, PSA, DICE. Yeah, so this leads to the decision of, well, how do we actually what is the correct way to opaquely carry all of these things? So definitely we all agree that it needs to be treated as an opaque blob. We definitely agree that the attester and the verifier need to understand the evidence format, but the box in the middle, the CA and RA do not, hence the passport model. Next. This brings to the open question though. So you do want some sort of type value pair. That is really the only content of this draft, is that the CSR attribute will be you can specify what the type is going to be, and then you provide the bits of it. The open issue then is, what exactly is that type specifier? Should it be an OID? Should we be able to register OIDs for public common attestation types like WebAuthn as a wrapper, and then allow proprietary attestation vendors to register their own OIDs to say this is a EnShield attestation inside? Or should we use the RATS conceptual message wrapper? And this is sort of a philosophical debate I think we probably need working group buy-in for. The design team started, so I see there's people in the queue. I will note that the design team, that is the HSM vendors, have a strong preference to stay with ASN1 and PKIX modules, which is how this group got started in the first place. If we were amenable to just using like WebAuthn or RATS conceptual wrapper directly, then we wouldn't have done this work in the first place. So strong preference that we want to stay within ASN1, which sort of implies that OIDs is the way that the design team here wants to go. But I think this is a debate that needs to be had by the working group. I can take from the queue.
Yeah. Hank in the room. He's in the queue.
Yeah, I'm trying to. Oh, it works. Finally. Yeah, sorry. I'm close by. I'm in the building. Unfortunately, not in the room. Sorry for that. I will be in the room later. Yeah, I see that. So I'm taking the hat of Thomas Fassati on here, who is like a strong supporter of doing the message wrapper here, and I can see why, because you're doing the background check model, and I have to. I think we have to have a good understanding of the pros and cons of staying with OID-based. We have an OID-based identification scheme also in the COREM, because we can't get it out there. It's just too fossilized in there. But I think there are good reasons to really take into consideration the CMW. So that discussion really has to be, I think, orchestrated and well prepared.
Watson?
Watson Lad, Akamai. I guess I'm not sure why there's a difference here. Because you don't always throw the integer in as the last arc component of an arc and make it the same. I do think when it comes to RATs, like, you're not, if I understand the problem correctly, you're not really interested in all the wide world of attestations. You're interested in some big set, but a subset of them for the ones that come from HSMs and tell you, yes, this key was generated in the HSM. It matches the requirements of the CAB forum. Or are we thinking that down the line, we might want even more kinds of things, and alignment with RATs would be great?
Yeah, so you've hit another philosophical sharp edge here, which is, are we designing a mechanism specific to the CAB requirements, or are we just doing, here's how you put an attestation in a CSR? And I think there's varying points of view on that question.
In short, I think what he's saying is this group of people don't agree on whether they're just solving for that 1 point requirement or they're trying to address the broader requirement.
Well, even this Hannes, even that group that you showed previously already has a number of different attestation technologies in use today. So there is already the question of, like, how do you indicate which one of those you are passing around? So, but of course, as Mike said, you need to somehow indicate that type. What is the encoding for that type? And yeah, the pros and cons, and we haven't figured it out. So further work.
Okay, I have one more slide. Two. Right. Yeah, so the other open, I mean, that was the big open issue. Some other smaller open issues. We currently define two attributes, an attest attribute and an attest certs attribute. So that's one of the requirements here is you should be able to put multiple attestations into a CSR. You might have a platform attestation and a key attestation, or you might have multiple key attestations looking at PQ. You might want to attest your key on multiple algorithm chains, for example. So we definitely need one or more attest attributes. We're currently defining 0 or 1 attest certs attributes. So that's a cert bag of all the certs that may or may not be useful for validating these one or more attestations. There's been some debate about whether we should stick the cert chains inside the attest attribute and only define one attribute, which seems cleaner because then you can associate cert chain to attestation easier. But if you have multiple attestations that share a cert chain, then you're duplicating the certs. And yes, the last point there, size, you're going to embed multiple potentially long cert chains inside a CSR. Won't that make the CSR huge? Yes, which is the reason for not duplicating them. Yeah, and then the other sort of related debate there is some attestation statement formats, like I'm looking at WebAuthn, already carry their certs inside. So for us, they'd be inside the opaque blob already has the certs. Other formats like TPM, TPM attest do not. The certs need to be carried separately. So that's always the cert bag is always going to be optional. There's a bit of fancy footwork here. I propose the way we have it is right, but I wanted to raise it for attention. And there's one more that Hendrik raised, which is not on the slides proposed yesterday, which is this mechanism isn't CRMF friendly. So I'll need to work with Hendrik to figure out how to make this CRMF friendly.
Ned. Where's Ned? Ned?
Ned Smith, Intel. So I'm a little confused by the terminology where you say attestations. I think that's sort of ambiguous. It's not really defined in the RATS architecture. If an attest attribute here is intended to be evidence, why don't you just call it evidence attribute? Similarly with certificates, if it's a certificate chain, just call it that. And I don't know if you can answer that. There's also, in the context of the use cases, I don't know if you're considering putting attestation results in some way in either a CSR or in a certificate. I didn't see that described in the draft.
The assumption on that picture is that the CA or RA is communicating directly with the verifier out of band somehow, not through the CSR. Hannes, do you want to answer that question?
Yeah, so Ned is right, it's evidence, so we could align that terminology. I think the ASM1 dates back to the time before we made the terminology change, so that's a kind of a leftover. It's like from a scoping point of view, I think this slide also nicely shows the nonce is covered outside. And likewise, what would go into, if anything, goes into the certificate that is issued by the CA as in response to all sorts of evaluation. That's also not described in this document, could be described in a future document, like the thing that was also discussed where maybe for the for specific CA browser forum based attestation, there could be some specific details on how these different data could be munched together for certain attestation technologies. Also not described in this document, could be done in the future.
The X509 cert extension thing, I think we're about to have to step into, though. My understanding is to make it CRMF compatible, we're going to have to define an extension, and that's going to be a little bit weird because we're explicitly not telling you how to carry attestations in certs, but we might end up having to.
Sander?
Sander Tema, Fortanix. We're a HSM vendor, and yes, we would like to embed certificate chain in the CSR itself, with deduplication if possible because of size considerations, especially if we're talking about larger keys or quantum algorithms or what have you. Yes, the word attestation is overloaded. But this is specifically for the provenance of the signing keys for those code signing certificates.
Yeah, I like Ned's suggestion of stripping out attestation and replacing it with evidence. That
yeah, because you may have attestation provenance attestations built by specific instances that need to make themselves known, even if they roll up to the same trust chain as other infrastructure. Thanks.
I think my last slide just says adopt question mark. Oh no, it doesn't. There's more stuff. Yeah, it does say adopt question mark. It also says, can we drop the other ones? And it says this design team is gonna keep meeting every 2 weeks. So I think this work obviously will deal with anything the working group wants to get this work adopted and moved forward. There is some time pressure in that the longer this goes, the longer we don't have a good automated mechanism for it. The next step for the design group is we do want a public standardized attestation format that I guess, so the goal of phase 2, and I don't know which group will submit this to, not LAMPS, maybe RATS, but we're going to come up with an attestation format so that the CA doesn't need a proprietary verifier. So the CA can look at the attestation and know whether it meets the CAB requirements, FIPS mode, level 3, et cetera, without needing to outsource out to a third-party verifier. So that's the next step, and that's going to be probably a lot more controversial than this in terms of design.
Sorry, Deb Cooley. So, it's better than standing on my tiptoes, though, right? So code signing is all you're worried about here?
Officially, yes.
And all the people all your authors on your drafts are only worried about code signing?
Officially, yes. What's your question?
No, I'm just looking at scope creep, that's all.
Me
It's
too.
just code signing. It's easy, right?
Yeah.
Well,
Yeah. You should join our Monday meetings.
Yeah.
They're fun.
I think like what's current. So the document defines a transport, and a transport is like the code signing requirement doesn't impact the transport in any reasonable way. I think that's a policy issue.
To the extent that it's a scope of working group document thing, I understand what Deb's saying, and that totally makes sense. But what you're trying to say is if somebody wanted to do the same thing for another use case, the smart thing to do would be to reuse this technology after it's already been standardized instead of inventing something new. And I agree with that.
Hello, Sean Turner. I figured out how to get in the queue. So on the first point, I think I sent something to list, but I guess I just want to confirm you can take the name of the draft that got admitted that was mine or not, your call, but I'm happy to have you mix it off with this grand group of people as opposed to just me and Carl working on it. So thanks.
Hi. Well, you knew that I was going to raise threshold. I mean, the frost draft is getting through CFRG. And since you bring up the idea of we're going to have a FIPS thing, please, when you write whatever requirements, make sure that we can still use threshold in a mode where there is a FIPS part, share, and there is a share held by the user. Because I think that that's probably going to be a use case that you want to end up supporting, because that's just the right way to do it eventually.
I don't know what you're talking about. Can you fire me some reading materials on list?
Yes.
So I'm channeling Carl Wallace. She says, defining an extension does not mean for certs. The prior draft ought to have language to support extension or attribute, which was the point on the list. No code signing is not all that is of interest to the group at large. The already accepted draft predates the code signing focus.
Yeah. Good point. Yeah.
Well, when does Carl not have a good point?
Yeah, I think I am the third or fourth person in a long line of this ought to be simple, and you try to do it, and it scope creeps.
Okay, is there anyone who objects to us having a call for adoption of this document? Okay, thank you.
Can I sit down now?
You can sit down now, yes. What's next?
Lithium certs.
Okay. Okay, there's dilithium certs are the next topic. I did not get slides, which I think means there's not much to say.
That's perfect.
This will be very quick. We're still waiting. We haven't updated the draft. In August or September, I'm planning on putting some examples in the certificate that Boz very nicely hooked me up with in the GitHub repo. I press a button, magic happens, but that's it. So for both of these drafts, we'll get them aligned and get them going, and then we'll feast and profit once we actually get some wins.
Kyber certificates.
That's the other one you mentioned.
The next one we've already talked about because it went to the ISG. And then we have the X509 policy graph from David Benjamin. I did not see an update for that. And then we have the cert binding. Who's talking, Allie?
Okay.
Too short. All right, yeah, super quick. From the last meeting, we generalized it, so now it's just Cert A related to Cert B. So that's how the whole draft is written, and then we have a use case section at the end that discusses what to do for PQ and traditional, because that was requested. We made a couple of clarification edits that were requested on list. And at the hackathon, Brendan Zumber had an implementation running. I don't think we had any interop yet, but that is the next thing that we're going to try to do. So that's it.
Okay. Any questions? All right. Now we're moving into the SMIME related documents. Kyber, Julian, I think, is going to speak.
Yes. Can you hear me? Yeah.
Barely.
Yeah, okay. So hello everybody. A little update on the Kyber CMS draft RFC. So actually the draft hasn't moved since last meeting, and I'm currently working on the implementation to generate some test vectors that will be included for the next meeting maybe. So well, that's it.
Okay, thank you.
Thank you.
The next one's Sphinx Plus. Baz, do you want to talk or do you want me to do it? Okay. The document here has had one update, which picked the ones that we were planning to support. We're waiting for the Sphinx team to tell NIST whether that set is the ones that are going to move, that they want to move forward. And if whatever happens there is we will align, but that's our crystal ball is what's in the document. ChemRI.
So yeah, so this is the key encapsulation mechanism. You can go to the next slide, Russ. So it's Tomofomi, Russ, and myself. I'm not really going to go over the slide much other than to say is it's being used by RFC 5990 BIS. We're also using it in our composite chem draft. And we took inspiration from of this draft in the CMP draft, which Ken Hendrick already talked about. So just go on to the next slide. Yeah, so this draft's in working group last call. Well, the working group last call ended on the 14th of July. So all the issues resolved on the mailing list except one. This was to do with just the UKM field. It's an optional field, but in cases where an API or a chem algorithm doesn't support, or yeah, it's not needed, then there's some questions about that. So that question was raised. And then there was kind of the contrary question raised that, well, in some cases, we should always support this. So anyway, if you go to the next slide, we've come up with some text to try to resolve that little bit of tension. So I'm just going to read the one line. And I think it's towards the end. Yes, so implementations that do not support the UKM field should gracefully discontinue processing when the UKM field is present. So that is essentially, the rest of it remain the same. Well, we did actually add one little part about the For example, the UKM value could include an application-specific context information. We just want to be clear that the UKM is used as an input to the KDF, and it's usually for context-specific reasons. So if you go to the next slide. I'm trying to do this really quick because I know there's a lot to go and do. So does that text, I don't know if anyone's looked at that text other than we just showed it. Does this represent consensus in the LAMPS working group? So we think David and Mike Jenkins agreed with that. Does anyone else have comments about that? And if not, what is needed to be changed? So any comments? Or does everyone agree?
So that text was posted to the list last week sometime. And since the last call has kind of ended, we're kind of waiting for people to digest it and make sure it meets their needs. If it does, we'll send the document to the ISG. If it doesn't, then we want to update.
Yes, let us know.
That one paragraph. That is the only part that doesn't seem to have achieved consensus as of last week. All right, Tim,
Okay.
Next week you get to tell us.
5990.
Sean, 5990.
Sound like a broken record. No updates. This document is not affected by the 5990 or the ChemRI changes that you made. So we're just kind of waiting at this point.
Okay, next. Composites. Oh, another short one.
Yeah.
I'm here to back.
Okay, hi. Next slide. Okay, so the call for adoption happened. I assume most people in the room are aware, followed that debate. So composite chems passed the adoption, composite signatures did not. Tim, can I put you on the spot to summarize where you think, like, working group chair position on, is this dead yet?
So about composite signatures or composite chems, or what are you putting me on that spot for?
Signatures, like you've done a spiel already at two.
Yes,
different
yeah,
working
okay, thank you. Exactly. Composite signatures are not dead. The approach that was in the drafts that were put up for the adoption call, people did not like how that was done. Composite signatures, signing things remains important. It turns out to be, again and again, a lot harder than people think. Although chems actually turned out to be easier than I thought. So I guess it does happen sometimes. But so yeah, we're, it's there, no matter how long you work on an RFC, it doesn't automatically get to pass the adoption call just because you've been working on it for a long time. It actually has to be the right approach and the right way forward. So we're still looking for the people to figure out what's the right way to do composite signatures for PQC transitions.
So that thank you, Tim. That explains why we are stubbornly still working on this document that has failed its call for adoption. Because we do believe there's a real problem that needs to be solved. Clearly, like, there's not consensus of exactly what the problem is, and the solution may need to change when we get consensus on the problem statement. But in the meantime, we're going to continue refining the proposal. Yeah, so we sort of whittled out what the core objections were from the call for adoptions for SIGs. So to quote from Tim there still needs to be some serious conversations with exactly what we are trying to achieve and exactly how it's supposed to work. Yep, agreed. This whole strong non-separability discussion that came up recently is fascinating and academically interesting. And is it, so that's the, we have one camp saying this isn't needed at all and one camp saying it's not strong enough. Yep, cool. And then the other category of objections, there was a fair amount of holdover from, like, this draft has changed a lot over this 4-year run. And there was a lot of OR mode generic, it's not there anymore. If you check the current draft, all of that is gone. So there was a lot of objections to the sort of soft wishy-washy, like that's all not in the current draft anymore. We've really tightened it down to just be an add mode, and you don't get to choose your algorithms. IETF will fix them in a registry. So I think some of these objections, I hope, were safe to ignore as being vestiges of previous versions. Roman?
Yeah, you don't ignore this.
Yeah, on the hi, Roman Danilio. Just for number 2, kind of on the list for those that weren't in Sec Dispatch, to kind of quickly replay that particular draft did come for a dispatching process, and I would say it got kind of mixed feedback. There were definitely some folks in the room that did not understand why someone would kind of want that, and they were not so enthusiastic about it. So I can't properly kind of summarize everything how we got to the last draft, but I would say that broadly in the area outside the working group, we're also kind of having those same questions.
The same question, yes.
Some version of the same question.
Yes. And while I have the electronic talking stick, I'll make the point that this debate, I think, is harmed when people say hybrid signatures aren't needed without qualifying what context they're talking about. Yep. If you're talking about a negotiated protocol like TLS, that is a very different context of the word not needed than if you're talking about long-term.
Yeah, precisely right. Yeah, I'm sorry to have misspoke. It was definitely clear, at least for me from the Sec Dispatch conversation, that folks had a very different non-uniform kind of perspective on it. We're coming at it from a different problem, but we're saying the same thing kind of in the end. And we probably needed to disambiguate all of that, kind of pull it apart.
Yeah, so I'm putting a plea. I'm putting a plea to the community when you vouch an opinion on hybrids, please qualify it with whether you're talking about a negotiated, short-lived, the signature only needs to live for 3 milliseconds versus a non-negotiated, it needs to live for 30 years. I think those qualifiers are really important. I think we do the discussion a disservice when we don't qualify our context. Next slide. Okay, here's a checklist of nits and edits we need to do for composite chems. In the interest of time, I'm not going to walk through them. I don't think there's anything particularly controversial here. All of this has been well hashed out in the discussion on list. The last one is sort of fun. We have a DH chem for CMS draft that we have written but not put on data tracker yet. So the way we want to do the hybrid chems, we need obviously Kyber is a chem and ECDH is not. And the way we want to merge them is by promoting ECDH to be a chem and then merge a chem with a chem. To do that, we need a DH chem for CMS draft, which doesn't exist. There is an RSA chem for CMS. There's RFC 5990. So we already know how to merge Kyber with RSA, but we don't know how to merge our Kyber with ECDH. So we've been sitting on this draft. We haven't put it on data tracker yet because I wanted to let all the craziness die down. But we have another document which is going to be a prerequisite for this one.
You don't have an asbestos suit yet.
Sorry?
You don't have an asbestos suit yet?
Yeah.
Yes. So itchy, yes.
And yeah, composite SIGs is a much shorter list of to-dos. That's because composite SIGs we've actually put a lot more effort into. In some senses, it's actually a lot more mature than chems. Yeah. Cool.
It just doesn't have consensus.
Right. Yeah. So the last sort of actual design change we're going to make is currently we have flexible parameters for RS. Like we do not specify RSA key size, and we allow you to carry the RSA PSS params. I think working group consensus is we don't want params at all. So we're gonna, instead of saying RSA with dilithium, we're gonna say RSA 2048 and RSA 4096 with, and we're also gonna tell you which RSA PSS params, KDF, etc. you're going to use. We're going to make that not flexible anymore. Yay, I've made DKG happy. Okay, that says 5 of 5, so I think I can sit down now.
Any questions for Mike? Okay. Wait, Florence.
Hi, Flo Driscoll, UK NCSC. I guess just a comment on a few slides back when you were asking about what properties needed in hybrid signatures, or for whatever use case you would like. I'm not specifying. I think what would be really useful is to see the use cases specifically. It's difficult to work out what properties are needed if we don't know where this needs to be used.
Interesting.
Yeah.
Point.
So since you brought that up, I mean, one of the interesting discussions is in the context of certificates and outside the context of certificates is a really important difference. If your protocol uses bare public keys, then maybe you need the signature primitive to do the binding. Whereas if you have certificates, maybe you can cheat, and that's okay. Thank you for bringing that up, Flo. I think the context discussion on what properties you need in the context of your protocol is yeah. Yeah, it's all part of this first. The intro needs stronger mode driving use case, and that's security properties is definitely a valid part of that.
Okay, Corey, I think we're going to talk about 5019 BIS. Oh.
Yeah, about 5090 BIS.
Yes.
Please. Yeah.
Thought Corey was talking. Sorry. Go ahead.
Next. Oh, yeah. As highlighted, NIST published As highlighted, NIST published the plan to transit away from the current limited use of SHA-1. So we are planning to migrate from SHA-1 for OCSP cert ID. Next slide, please. Yeah, so right-hand side is like protocol specification of OCSP cert ID things. And at the right-hand side said, like 2560 or 6960 or doesn't restrict use of like SHA-1 or any hashing, or sorry, it's defined cert ID without restriction of hashing algorithm. But for some profile for high volume environment, like we define like left-hand side, we define RFC 5019. We mandate use of SHA-1 for other profile for cert ID, and our plan is is to allow use of SHA-256 for like cert ID, and actually at right-hand side 6960, like some implementation has already support SHA-256, but like I'm not sure reason, but like some implementation only supports SHA-1. I think that is because of 5019, and we think like we had better move away from this situation and support SHA-256. Next slide, please. So what do we want is like just to word adoption, and we want to migrate from SHA-1 cert ID to SHA-256. Yeah, that's all.
Why is there more slides?
There is some like additional information, but supplemental information. So if you are interested, yeah, we talk about some migration plan and some potential question, but like. Yeah,
okay, so there's backup slides on the data tracker if you want to see them. Go ahead, Jonathan.
Sorry, Jonathan Hoyland, Cloudflare. Why SHA-256 and why not just any hash? Like SHA-3 is out now. It's been out for a while.
Yeah, but, well, because like if we support many hashing, for example, like for CDN environment or those kind of high volume environment, we kind of need to pre-calculate like OCSP response, and like I believe we had better limit use of like we had better limit the number of like hashing algorithm. And
Oh, so you think just SHA-3?
SHA-3, yeah, but like.
Right, if you only want one, right? Go for the new one.
It's slower.
If you're pre-computing, who cares? If you're pre-computing, how much, like, we're talking milliseconds. So if you're pre-computing it all, who cares if it's slower by like what?
Well, but we pre-compute with HSM. The limitation is much more. Yeah, some CA have so many certificates. Yeah, so yeah. And anyway, we might migrate to Hawaii.
Okay. Deb?
So shiny objects?
Talk to the mic, Deb.
Well, I think I am. So shiny objects?
There's only one mic, sorry. The point is when we're here in 40 years time and it's like, oh, it says SHA-2, we've got to keep using SHA-2, and it's like, right, but now we know how to like immediately generate collisions. It's like, right, but the spec says SHA-2. Like, let's skip SHA-2, go SHA-3, it's fine.
Why do you believe that SHA-3 is stronger?
It's
newer.
Yeah.
So I'm correct. It's a shiny object thing. SHA-2's faster, and it's not a problem.
Okay, Watson.
Watson Lad Akamai, I like this draft. I am really concerned about, just from looking at the authors list, it's not clear if like the WebPKI people are like, what's their attitude on this? Because migration that breaks OCSP for a lot of clients out there, well, okay, OCSP doesn't really matter in the first place, but it would be really sad if we had a situation where we don't understand the migration path and we don't have one because of the huge number of browsers and devices out there relying on the WebPKI that might only support SHA-1. So we need to think about that. Sorry to be sad about this.
Interesting, because you're calling out the WebPKI where that's the one place where OCSP isn't taking off.
So OCSP and the WebPKI, the one thing is it is required to run the responders, and it is something that, yeah, the browsers can't rely on in all the places, but they still require to respond. Yeah, maybe it's okay to break it, but we need to check first.
Oh, absolutely.
Yeah. Yeah. Hi, Sean Turner. So again, right, the 1519 one is the profile of the high volume. If you want to support 20 different algorithms, that's generic OCSP. So we were just going for the high profile one. And to Watson's point about like, hey, let's not do this unless it's going to get support. That's one of the only reasons why I put my name on it, because people actually were like, well, we might actually use this. So my kind of attitude is let's go for the super low hanging fruit, because there's a whole lot of certs out there that do SHA-256. So the chance of them actually being supported is quite high. And then this will allow people to get rid of SHA-1, and then we all profit. If we need another one for SHA-3 or your favorite whatever, great, we can do that one too later. But like we ought to be able to iterate these things without going for the gold-plated one now. Let's just go for the low-hanging fruit and get it done.
Yeah, I
Please make sure you're talking to the mic. Remember, there are a fair number of remote participants.
I did try to get myself in the queue. I couldn't. Yeah. There is basically, Phil Baker, basically the result of the SHA-3 competition was we discovered that SHA-2 wasn't that bad. But we'd already committed to having a 3. The only reason in my mind for insisting on 3 is if we were going to force people to implement 3 in the browsers. I don't think that that would have that effect in this case. And we've already done that with ED 448, which depends on SHA.
Right. Quinn?
I'm Quinn Dang at NIST. For this purpose, to me, SHA-256 or SHA-3, they are both fine for the job. About, say, SHA-256 is faster than SHA-3, that is not accurate in what I understood. For SHA-512, and then if you run on the new machine, the 64-bit machine, and then it's a little bit faster than SHA-3, but not the same as SHA-256, because SHA-256 is the size is half shorter, so you don't take advantage of the FSMD instruction to split it into multiple thread. So that's why if you want faster, SHA-56 is not the one to choose to beat SHA-3 in performance in software. But even in software, SHA-512 is not that much faster than SHA-3 in software. A little bit, but not. But if you run in hardware, SHA-3 is way better than SHA-2 SHA-2 is not the one to do fast in hardware.
Yeah, like currently we have implementation for SHA-256, and I'm not quite sure about. I research for SHA-3, but like I don't think we have that much implementation for SHA-3, and like if we want SHA-3, like we need to implement and migrate. We need to do those kind of things, and so like. Yeah, it will take much more time to migrate, and I think if both is okay, I think SHA-256 is a good way to go. So, yeah.
Jonathan, did you put yourself back in the queue? Now you're not. Okay. All right. Is there anyone who objects to a call for adoption? Okay, that I'm not. Good. Next on the agenda. No. I did not get slides for key compromise attestation. Does anyone want to talk to that? Huh, there was a big thread on the list. Okay, we're done with, we're up to Chameleon.
All right. So I'm going to be presenting today a draft from myself, John Gray, David Hook, Tomofumi, and Mike Owensworth. So in the background here, we have a picture of a Gundam. We thought that was very timely, given that we kind of developed this idea in Yokohama. But for copyright reasons, we will likely not be using that name. So we decided to go with Chameleon certificates. Yeah. All right. So first off, we'll start with the problem statement. Subjects often have multiple related certificates which certify different keys. In one such scenario where this would happen is you have an algorithm migration. You have a key pair that uses a legacy algorithm, and then a key pair that uses a new algorithm. And a single subject entity would then have two certificates issued to it that certify separate keys. Another scenario would be dual use. So for example, for S-MIME, for example, you would have a signing key and an encryption key. These would be represented with obviously different key pairs and different certificates. And question arises is how do relying parties obtain the most appropriate certificate? And how can multiple certificates be transported through protocols that might have restrictions on multiple certificates? A single certificate is expected. Next slide, please. All right, so an alternative approach that we came up with in Yokohama is two X509 certificates with public keys, and it's pretty straightforward, very traditional approach. They will have different serial numbers, and you don't have any modification to the certification path validation algorithm specified in 5280. The idea that we have is that you have one of the certificates issued. We call this the Delta certificate. You then take a look at the to be signed other certificate, which we call a base certificate, and calculate the differences. You then contain all this information inside an extension, which contains the differences and also contains the signature value of the Delta certificate. You then put this extension within the to be signed base certificate, and then you sign it. What this does then is you can now efficiently convey two different X509 certificates within one certificate. Next slide, please. So this is kind of the idea that we have, not naively, kind of what we already discussed, it's a single key pair, single certificate. There's no interrelationship. So on the left, we have a traditional algorithm certificate, RSA key pair. And then on the right, we have dilithium 3, entirely separate. Next slide, please.
I'm sure Joe means example, right?
Yes. So the idea is when you go to reconstruct, as we already talked about, you have the Delta certificate descriptor extension in the base certificate that contains the signature value and also contains all the differences from the base that basically comprise the difference between the Delta certificate and the base certificate. And using that information, the relying party can then reconstruct the Delta certificate. We have some limitations in the specification on like extension ordering and extension presence, things like that. I guess next slide, please.
Yeah, otherwise the signature doesn't work.
Exactly. Yeah. Yeah. So we did take some opinionated approach to what is allowed to be different. So you can have obviously different signature algorithms, different subject, different issuer, in validity period. Those might be a little more controversial, but we were thinking that the issuer DN difference would be valuable in the case where your PKI doesn't have key rollover. You basically have a one-to-one mapping of CA keys to CA names. So your dilithium chain, the distinguished names in there may have different names. Probably could abuse that potentially a little bit beyond that, but that was the intent of putting that in. But these are the potential fields that can be different. And again, as I mentioned, the extensions have some further restrictions defined in the document, such that you can't add or remove extensions that exist in one certificate but not the other, just to ease the encoding and decoding complexity. Next slide, please. All right, so we're going to talk about relying party use. If the client in an online protocol can send its supported algorithms, then the server in that protocol can send either the base certificate or Delta certificate. In this case, the client need not implement the specification. So in a case where you have many thousand different clients, but a single, say for example, an single application server, you could merely implement this on the server side. And when the client goes with its initiates the handshake, it specifies the algorithms it supports. The server can selectively send one of these certificates based on that information. And alternatively, the relying party, the recipient, can also extract the Delta certificate as needed. As mentioned previously, no modification to the certification path algorithm, validation algorithm is required. The only difference is that the path or the way how collection of the certificates that logic would have to change, right? The logic that would go and potentially do AIA chasing or going and checking like an online database of like intermediate certificates in the case where a server might not be sending those along. This would just be an extension of that. And this also allows the base certificate algorithm to be seamlessly migrated to the Delta certificate without legacy overhead. So if, for example, you have in the case where you have your dilithium certificate is your base certificate, and then the Delta certificate is an RSA certificate, the server can extract the RSA Delta certificate and send that to the client. Next slide, please. All right. So we do have 4 implementations of this right now. We have one in Rust, 2 in Java, and 1 in Python. We've already received some excellent feedback on this draft that we've integrated and are continuing to integrate. And we welcome suggestions for improvement. If it's not too premature, we would like to consider a call for adoption for this. So thank you.
Well, you stimulated interest.
Okay. Okay. Scott Fleur, you mentioned that you can use this property to switch between RSA and dilithium. However, to have a real dilithium path, you really need to have the root certificate be post-quantum. And if you're RSA only, obviously you're not going to do that. So it doesn't, to me, appear to be solving that particular use case.
So the intermediate case and also the root certificates as well could also be chameleon certificates, right? You could have a base certificate, and then within that you have the delta certificate as well that represents the root.
So you'd have delta for all the signatures and all the public keys in the cert?
That would be one way to do it, yeah. If you need that to complete the path validation.
Watson Ladd, Akamai Technologies. I don't understand why this draft does what it does, because if you are if you need to convey the certificates this is really sort of a special case compression algorithm, it seems.
Yeah.
And we already have a way to do it that doesn't require any changes to the PKI. It's called zlib. And we use it, right? Just now in TLS, there was a whole discussion about, okay, how do we go through the chain and separate out common extensions, et cetera, across the entire chain. So this method seems to be a much more limited one where you're not going to be able to apply it as broadly. And it's going to have implications for sort of, let's say you have a PKI, you've issued some certs, you want to check what certs you've issued. And oh, there's this whole hidden set of certs that your tools might not know about or do know about in different ways that's created through this extension. That to me seems a lot worse than convoluted compression.
It's the opposite.
Oh, if you want to go to, yeah, go ahead.
I do too. So. Can you go back to the pretty picture slide? Mike Ainsworth answering.
The which slide?
Pretty picture.
Yeah, that's a good.
Oh, well, that was the first slide.
Sure, that'll do.
That one?
Next one.
That's a pretty one. Yep.
Yeah, that's the one. So the thing that zlib doesn't compress
to the
is
mic.
the thing that zlib doesn't compress is the public key, which is the thing that this allows you to skip. So the entire point here, and those who remember the Catalyst proposal, this is sort of inverse Catalyst in the sense that this allows you to drop the large PQ key when you don't need it. You cannot compress out a large PQ key, but you can drop it.
Right, but the only reason you can drop it is you negotiate you didn't need that cert in the first place. And if you can negotiate you didn't need that cert in the first place, you just don't send it. We do this in TLS all the time. What is this getting over that? That's what I'm not understanding.
Nothing.
So that was one of the points in the early slide is if you have a negotiated protocol like TLS, you don't need this.
Right, and then there's no client overhead on implementing this. It would just merely need to be implemented on the server side.
Stephen, you can probably guess.
Yeah, Stephen, you're right.
Yeah. So you take that as said. It's a bad idea. I think.
Oh, you're right about the other thing too.
Yeah. What application is calling for this today?
So one idea that we had at the hackathon was we were going to potentially use this as TLS, but we were also thinking this could also have use in signing like CMS as well.
Okay, so I'm unaware that any of the TLS implementers or protocols using TLS or applications that use protocols that use TLS are looking for this. If that's not the case, then maybe it's different. But if it's not really needed, if it's over complex things that change code at the wrong level, at least in my opinion, I don't think it should fly.
Daniel Kahn Gilmore, ACLU. So help me think through the implications of something like this for a client. So, okay, as far as the compression stuff goes, this is useful where protocols only allow one cert. That's the one place where this is useful. A protocol that only allows one cert with no negotiation, you can just feed a big thing and let the client figure it out, right? That's the use case. So in that use case, I'm a client and I receive a crazy certificate that I don't really recognize. I don't even know the algorithm for the signing key. I don't know any of these parts. I don't know who the issuer is. It doesn't change anything that I understand. I can't validate it cryptographically, but you've just given me a blob, and now I have an arbitrary number of ways I can transform this. How many times can I put this extension in?
Just once.
Are you sure?
The draft says so right now.
And what if this, and if I put it in just once and but it lets me add extensions, right? To the Delta cert. Does the Delta cert let me do this?
No, that's also prohibited by the draft. Yeah.
Okay.
Yeah.
So, so just to be clear, this is a mechanism that lets me as a client, where I expected one cert, I don't have to change the protocol, but where I expected one cert, now I have two certs.
Yep. That's correct. Yes.
Exactly two.
Yep. Yes.
And if I can't figure out what to do with either of them, then I bail.
That would be correct. Yes.
But in a place where I've also got a cert chain, each of those certs in the cert chain, I also have two.
Yep. Potentially, yes.
Why aren't we just changing this protocol to allow multiple certs?
Hi, this is Hannes. I think at the minimum, the document title needs to change and the problem description of the document, because it's very confusing. When it comes to the use in TLS, I have over the years seen that there are numerous attempts to compress, omit, and otherwise shrink certificates. And I have contributed to some of those proposals. And here's the funny thing. Every time I read a new proposal, it says, there are all these previous attempts, but they are not widely implemented. I now have a new one. And currently we have at least 3 such proposals actively being worked on. And they basically, proposals come faster than the old ones who said they solved the problems that the previous ones didn't solve, to sort of show up. It's really funny. So I'm actually wondering whether the size of the certificates, that is, of course, a big contributor to the handshake, is actually a problem in the real world. It's an optimization that seems to be maybe not enough for people to actually then go all the way to really deploy this stuff. A little bit cynical in view after years of working on this.
Yeah.
Yeah, John Gray, one of the authors of this as well. One of the things that when we were thinking about this, because Corey mentioned the Truskowski draft, the previous one, that was actually, I think, adopted by ITUT. But part of the thing is we're trying to look for tools for, we know this new PQ thing is coming, right? We're looking for tools for ways we can migrate our clients to these upgrade systems. This actually is one way that does it. So Corey described a use case, at the server side, but there's also the client use case where I could have like an RSA-based certificate. Inside that is like a dilithium Delta certificate. And then at some point in the future, when I want to migrate my system to dilithium, right? There might be this period of time where you're a bit uncertain because algorithms are new. So you can, with one of these certificates, it's still an RSA certificate. This is just implemented as an extension. That's all it is, right? So your RSA certificate will still verify by legacy clients. That's all fine. You can plug that into system today. It'll still work. You update that client at some point to understand the PQ part, new algorithms. You can verify both. That's fine. But then someday, maybe 2027, 2030, I don't know what date. Someday, maybe RSA is, deprecated or whatever. On that date, you can then just completely shed, the RSA skin, and then all you're left is with the dilithium, right? So now you've been able to migrate in a nice kind of seamless way. This actually gives us that. So that's just one of the use cases, right? Yeah, so that was my.
David Benjamin. So to add to DKG's point, not just you could have extended the protocol to support 2 certificates. You have to, because the protocol is doing something with the certificate. I know we said we're not using this for TLS, but any protocol is going to do something with the public key. In the case of TLS, we sign something in a certificate verify message. We also have these extensions that add SCTs or stapled CSV responses to the certificate. If the protocol expects one certificate, then all these little addendums are associated with that one certificate. And if your one certificate is now secretly 2 certificates, how do you know which thing you attached it to? You're going to need to extend the protocol so you know which thing it was attached to. At that point, you've now taught the protocol how to handle 2 certificates. So you could so not only you have to do that, and once you've done that, then you don't need to smuggle it into one cert because the protocol can just do it. You can just do it natively.
Yeah.
Wasn't a loaded term.
So I have a brief comment on that, actually. That's true if if the both certificates are actually involved in the protocol, but there's a large number of certificate protocols that largely exist for the purpose of transport and management of certificates and don't actually exist for the purposes of actually using the certificate. So in the case of issuance and certificate management, there are, there's some, I would love to extend every certificate management system in the world and every signature system and everything else to support natively 2 certificates and 2 keys, and we'll update everything and everything will be able to do 2 things, and the next crypto transition will be like, we already implemented crypto transitions. We know how to migrate from one key or certificate to another key or certificate. We're not in that world yet. Most of our systems are still very, very, they've got this built-in assumption that there's one guy and he's got a certificate and there's a key and nothing will ever change. And that's how we built the world, and bad us. So, this may or may not help with that problem. It may make it worse. It may make it better, but it's a, we'll see.
All right.
All right. I'd like to say this one needs much more discussion on the list before we get a call for adoption.
Am I up next?
Yes.
Yep. Okay.
If you go quick, we might actually finish the agenda.
Wow. Okay. All right. Well, I'm hoping this one is short and sweet and far less controversial than the previous one. So yeah, this is a RRC 8398 and 8399 BIS. Next slide, please. So we have 2 updates in progress, and the motivation is that implementation experience has proven that conditional encoding of domain names in the SMTP UTF-8 mailbox other name using either U labels or A labels increases implementation complexity and attack service. This has actually resulted in several real-life security vulnerabilities in one major implementation, namely OpenSSL. And the idea is that the fundamental problem is that the X509 stack now needs to have a Punicode decoder. So instead of using the U-label representation for encoding IDNs in the domain part, we would now be using A-label representations unconditionally. Next slide, please. So here's the old above, and here's the new below. So, much more simple, much more straightforward, and, less implementation complexity.
Looks like one's ASCII and one's not.
Yeah. All right, next slide, please. All right, and here is Russ's update to 8399 BIS. Apologies for the first bullet point. That should say update reference from 8398 to 8398 BIS. Made a mistake there, apologize. There's a note in the security considerations now that explains the rationale for this update. Next slide, please. If there's any feedback, great. We'd love to add that to the drafts. Otherwise, we'd like to call for working group adoption of these together.
Hello, Sean Turner. So in one of these 2 drafts, it points to IDNA 2008. Is there a later version of IDNA that they're going to make us eat later when we make this little change? I mean, I'm hopeful because Alexi's involved in this because he understands that stuff and how to navigate that crowd. But like, there's a real possibility of adopting this draft. I'm like, oh, there's IDNA 2012 and no implementation supports it. And so we're providing more input. If like IDNA 2008 is the thing that is implemented, then we've got all kinds of ammo to fight against the crazy changes. But that's what I'm hoping is we actually point to the right version of the thing. Still that version? Yeah, okay, great. So then we'll leave it alone, but maybe state up front, we're not changing it over our dead bodies.
Yeah, I'm only aware of IDNA 2008, and then there's UTS 46. Yeah.
Okay, all right.
Okay, does anyone object to call for adoption on this pair of documents? All right. Believe it or not, removing the duplicates about how all the attestation formats we were not going to talk about, we completed the agenda.
I'm glad that Steve Farrell came back because I would like to suggest 2 options for the L: lots of and loads of. It'll work.
we just drop the L and become amps.
Okay, that's it. And thank you very much, Flo, for taking notes. Wow, yeah. Woo, we did it.
Yes.
I didn't think we would.
I told
Well, that wasn't too difficult, was it?